All right. Today, now we are going to treat a past question on Math 121. Math 121 2016/2017 exam. Question number 1. Now, my question number 1, if you are having the past question 2016/17 of Math 121, my question number 1 may not be the same with your question number 1. But certainly, my question be in your own question, maybe in another number. Maybe my number 1, maybe your number 10, or number 5, or number 11. But if you just scan through, you find the same question on it. Because to improve security that year, they had to produce the question in types, but it is still the same exam. So this is my number 1 question. I'm going to solve it right now. Question says, find the displacement s of t of a particle traveling with velocity v of t equals to 3t squared minus 1. Given that s of 2 equals to 16. Now, solution. So we have to find displacement s of t. That means we have to find an expression, an equation for what the displacement s of t of a particle traveling with this velocity. And we have been given equation for the velocity. And then given that s of 2, that means the displacement at t equals to 2. These two represent t. Remember, we're talking about s of t. So when they say s of 2, that means t equals to 2. So given that at t equals to 2, s of t equals what? 16. That means at the time, 2 seconds, the displacement was what? 16 meters. So having given that, we are going to solve this. Now, the topic this question comes from is application of integration. Application of integration. That's where this question comes from. So if you don't really know that, you can check our course on our Math 121 course proper, where we treat each topic. We cover everything in each topic, and then broaden yourself on application of integration. So let's quickly solve this. So now, given v of t to be 3t squared minus 1. 3t squared minus 1. So we have to find what? We have to find s of t. Now you will recall that v of t is equals to what? ds d of s dt. As the formula for velocity, we know from physics and other places that velocity equals to what? Displacement over time. And so see, this velocity here is with respect to time. Depends on time. That means our displacement here will also kind of depend on time. But here the displacement is a derivative. You understand? The derivative with respect to t. So v of t equals to what? ds dt. And we are looking for s of t. So we're going to make d of s the subject of this expression, of that formula. So d of s will now be equals to v of t times what? dt. And we make that the subject. So from here, for us to find s of t, that's to remove this derivative from it. That means we are doing integration. We integrate both sides. So if we integrate both sides, that's integral of what? D of s equals to integral of what? V of t dt. So integral of this will give us what? S of t, which will now be integral of, and our expression for t is 3t squared minus 1. 3t squared minus 1. Everything times what? dt. You understand? We respect dt. So when we integrate this now, Remember a standard formula for integration. If you have an expression, say a, you have an expression, say ax raised to power of n, and you have to integrate this with respect to x, it will be what? Ax raised to power of n plus 1 divided by what? N plus 1. In this case, our n is 2. So here you'll be having 3t, that's 2 plus 1, that raised to the power of 3, divided by 3, divided by n plus 1, or n, which is 2 plus 1 is 3, minus, if you integrate this 1 here, that 1 here is like 1 x raised to the power of 0. Anything raised by 0 is 1. So if you add that equal to plus 1 times x raised to the power of 0 plus 1, that will now give you what? X raised by 1, which is x. So here you have x. Now plus your constant of integration. So now we've had an expression for s of t. So this is an expression for s of t. So this is what they are looking for. But however, this equation is not complete. Why isn't it complete? Because the constant here is c, we need to find it. The constant here is c, we need to find it. And how do we find that constant there? How do we find that constant? Now we were being told from the question that at time t equals to 2, that's s of 2, the displacement was 16. Displacement was 16. So if we now put s of 2 here, now s of 2 is 16. So in the place here, we put 16 here. Remember our s of 2 equals to thing. So we put the 16 there. 16 equals to 3. Oh, finally, remember this, we cancel that. This t equals to t raised to the power of 3 minus x plus c. Okay. So it will now be 16 t raised to the power of 3. That's, and our t is 2. That will be 2 raised to the power of 3 minus 2 plus c. That will be 16 minus 8. 16 equals to 8 minus 2 plus c. That's 16 equals to 6 plus c. And then you make c the subject of a formula. That's 16 minus 6 equals to 10. So we are finding our constant. So therefore, the equation representing the displacement, that's s of t, equals to what? T raised to the power of 3 minus t. This way is not supposed to be x, it's supposed to be t. Sorry about that. We are used to calculation x. Oh, it's also here. So here t. Sorry about that. Minus t plus c, and our c is what? 10 plus 10. So this is the answer to the equation that is being asked. Let's solve that. Thank you.